It's mine. I don't. It's not Hayvon's.
Why do we always get recorded? It's really cool.
So the internet's kind of shaky for a while, and it's like kick off the broadcast sometimes, and it takes a lot of bandwidth to do the recording. So I was more stable.
You just like it's better.
Yeah.
Yeah, that's right.
And y'all don't internet very much, so I don't have to deal with questions too much. All right, let's look at some quadratic applications. The width of a rectangle is 6 meters less than its length. The area of a rectangle is 112 meters square. Find the dimensions of the rectangle. So in the context of word problems, we got some things that we need to make sure we address. So when we find answers, we need to have the answer to the question that's asked in the word problem. So here they're asking for the dimensions. So what does it mean by the dimensions? Okay, so the length and the width. And when we state those dimensions, what unit should they have? The one that's used in the problem. So they're using meters squared for the area. So each side should be a length in meters out of that. So make sure that you're doing those things as you're dealing with word problems. Yeah, that sounds picky, but it is what I want you to do. So I'm going to hold you to it. All right. So first thing, very easy formula for area of a rectangle. How do you find area of a rectangle? Length times width. Yeah, absolutely. It's that simple. And it tells us that the width of the rectangle is 6 meters less than the length. So we don't know what the length is, but we know the width is 6 meters less than that. So what would that expression be? Yeah, just L minus 6. Real simple there. And then we plug in all of those things into that formula. We know that length is L, the width is L minus 6, and the area is how much? 112 meters squared. And we can take the units off while we're working the problem. Just make sure we remember to put them back at the end. And this is kind of a quadratic. If I distribute the L, I get L squared minus 6L equals 112. And now, for sure, I know that's a quadratic because it's got a variable squared. And so I've got to think about my different methods that I can use to solve that quadratic. So a lot of options on this one. Some are easier than others. Yeah, and that would get it equal to what? Equal to 0. So when we get it equal to 0, that kind of helps us be able to do one of two options when it comes to solve. What are the two options in which the problem has to be equal to 0 to use to solve? X method of factoring and not complete the square. It's related to that. Quadratic formula, okay? So if it was complete the square, we would have left the 112 over there on the side by itself if we were going to do that. Nobody really ever picks complete the square to solve with. Most folks don't. They just automatically get it equal to 0, and that either opens up factoring or quadratic formula. With this one, because it doesn't have anything in front of L squared, my thinking is factoring would be easy if we can figure out the numbers, because we get the shortcut to the factoring because there's nothing in front of the squared variable. Okay, so I'm going to do the X method or factoring for this one. So what goes up top? Negative 112. It's got to add to be negative 6. So numbers that multiply to be a negative 112 and add to be a negative 6. 8 and 14. Which one should be negative? The 14. Because it has nothing in front of, or a 1 in front of L squared, I can go straight to my factors. L plus 8, L minus 14. And then what do I do with each of those factors? Set them equal to 0. So L plus 8 equals 0. L minus 14 equals 0. So that's a negative 8 and a positive 14. Which one of those makes sense? Why not the negative 8? Yeah, because you can't measure the side of something and it come up to be a negative number, right? So we just throw the negative one away. And the length we know is 14. So length, start over, LEN. Length, 14 meters. The width is how much? 14 minus 6, which happens to be positive 8 meters. So we found the dimensions of that rectangle. It's not so bad. That was said a lot this morning, first block. So
where did the square go?
okay, because we're dealing with area, the dimension they gave us was the area. And area is a square unit because you're taking 8 meters times 14 meters, and meters times meters gets square meters. Okay, so when we're looking for the individual dimension for length and width, those are just going to be plane units. Okay, good question. All right, any other questions about that one? Let's try another one like that. Let's look at number 2 and see if you guys can help me set that up. So we got a length of a rectangle is 1 foot more than twice its width, and the area of the rectangle is 300 square feet. Find the dimensions. So what would be our setup for this one? All right, so the length would be 2w plus 1, okay? 1 more than twice the width. And so when we set up our equation, what's the left side going to look like? Yeah. There you go. W times 2w plus 1. And that should be equal to 300 because we're dealing with a rectangle again. We don't know the width, but we know the length is 2w plus 1. And then it's 300 square feet. You may have seen some of you that have done some Khan Academy have seen some pictures that were similar to this on there. So you were really doing some application problems, you just didn't know it. Maybe a little less work on your part to get the equation. So what do we do next? Yeah. 2w squared plus w is equal to 300. Subtract the 300. Yeah, that's what I would do. Again, I'm not against using complete the square to solve, but it's not fun. It's not my favorite method. My favorite method is factoring. So that's what I'm going to try here first and see if I can come up with the numbers. So what goes up top? Negative 600 goes on the bottom. 1. All right, so we need numbers that multiply to be negative 600 and add to be 1. So those numbers are going to be real close together. So I'm thinking 600. What goes into 600? Well, 100 goes into it 6 times, but that's not very close. So I think then what goes into 100? 25 does. How many times does it go into 600? 24 times, right? So it'd be 25 and negative 24. Excuse me. And then can I do the shortcut for factoring on this? No. So I've got to go through the steps of grouping. So 2w squared. I'm going to put minus 24w plus 25w minus 300. Again, it doesn't matter. You remember doing this from factoring. It doesn't matter what order you put the 2 middle terms in there, as I just did it in the way I thought it made better sense. 2w, that'd leave us w minus 12. Pull out a 25, be w minus 12. So our factors are 2w plus 25, w minus 12 equals 0. And we set those equal to 0. W is equal to 12. And then 2w plus 25. What kind of answer is that going to get us? A fraction and also negative, right? So we know that one's out. because we're talking about a length here, of the width of the rectangle. So we know we can't have a negative answer. Okay, so our width is 12. So let's read what the question asks for the dimensions. So we do need to find the width, be 12 feet, the length, 2w plus 1. So 2 times 12 is 24, plus 1 is 25. And again, I can check that because we're in the context of a rectangle. We know the original rectangle had an area of 300. What's 25 times 12? 300. That's what that means. I found the right dimensions there. Okay. Not too bad. Pretty easy. Questions about number 2? All right, let's look at number 3. It's actually a little easier than those two. The dimensions of a rectangle can be expressed as x plus 6 and x minus 2. If the area of the rectangle is 65 square inches, find the dimensions of the rectangle. Okay? How we set that up? And that's equal to what? Yeah, that's right. So not much different than the first two. The only difference is they gave us the two pieces. We didn't have to come up with them, and build them from the words. That was nice of them. What do I do next? Yeah, I need to distribute out the left side because I got to get this problem equal to what to solve it? 0, so that I can use either factoring or quadratic formula to solve that. So x times x is x squared. Negative 2x, positive 6x would be 4x minus 12. And then we would move the 65 by subtraction. We get x squared plus 4x minus 77. And that's pretty small number. So I'm going to try factoring first. Multiply to be 77, add to be 4. 11 and negative 7. That's right. Can I use a shortcut? Yeah. X plus 11, x minus 7. So x plus 11. There gets us a negative 11. This gets us positive 7. Which one of those do we keep? 7? Are we sure? Think about the context of the problem. Is x the length or the width of this rectangle? No, it's not. It technically could be either. If we take negative 11 and put it in for the dimensions here, negative 11 plus 6 is still a negative number. So that's the reason that the negative 11 is thrown out. Not necessarily, that it's a negative answer. Because if we had gotten a different set of factors here and got a negative, we need to check there because we're looking for dimensions. The x value in this problem is not a dimension. It's the answer for the x's in the description of those. So this one does get thrown out, but x equals 7 is not the answer they're looking for. They're looking for the dimensions. So if you put x equals 7, yeah, you worked the problem right, but that's not the answer to the right question. So we need to find out what the dimensions are. So we'd say 7 plus 6 be 13 what? Inches. And then 7 minus 2 be 5 inches. So those are the dimensions. Obviously, this is length. And this is width. So nothing too bad here. Rectangle problems are always usually pretty easy there. All right. Number 4. Let's get to some triangles. The base of a triangle is 7 less than twice its height if the area of the triangle is 102 square centimeters, find the length of the base. All right, so we got a triangle, and I'm just drawing a generic triangle. It may look like a right triangle, but it doesn't necessarily have to be a right triangle. I'm just drawing a triangle, okay? So the base of the triangle is 7 less than twice its height. So looking at this triangle, where would the height be? Be the left side, the one that's going straight up and down. So we don't know how much that is, but we know the base. What would be the expression for the base, the part that's on the bottom? Yeah, 2h minus 7. How do we find area of a triangle? What's the formula for that? Half times base times height. And so that's a formula that you probably use. You don't have to have had geometry to know that formula exists. If you don't know that formula, learn it. It's needed. All right, so we're going to plug in the stuff we know. We know the area is 102. The base is 2h minus 7 and times the height. That fraction in there could cause us problems later on. How can we get rid of it? Okay, the reciprocal of 1/2 would be 2. So if I multiply by the reciprocal on both sides, it'll get rid of that fraction and get us 204. And then what else do I do on the side with the 2h minus 7 and the h? Yeah, go ahead and distribute and multiply those out. Yeah, so that'd be 2h squared minus 7h. Now what? Subtract the 204. 2h squared minus 7h minus 204. And then we could approach that the same way we have the rest of them. We could look at factoring if you want to. So up top would be 408, negative 408, and negative 7 on the bottom. So what do we know about 408? Yeah, it's fairly big. It's got a lot of factors anyway. Will? 24 and 17. How'd you come up with that? Just started guessing? That's absolutely fine way to go there. When I'm looking at it with 408, I'm thinking, okay, it's divisible by 8 because the last two digits are divisible by 8. So then I got an 8 and a 51. I know 51 is divisible by 3. And so I'm thinking, okay, well, I need numbers that are a little closer together than 8 and 51. So 8 times 3 is 24. 8 divided by 24. That was my approach, but it still takes a guess at the start. Well, maybe it's a little more educated guess. But either way, you get 24 and 17. Which one should be negative? The 24 should be negative. So when we plug those in, minus 24h plus 17h minus 204. Group 2h, h minus 12, plus 17, h minus 12. So we have 2h plus 17 and h minus 12. Which of those do we know is the only one that we really have to solve? Because the other one is going to give us what? A negative, and the h is one of our dimensions for this problem. So that's why we know we can really just throw that one away. So 12, we're looking at centimeters for this problem. Is our height. Again, technically you're supposed to set this equal to 0, but you're going to get a negative answer, negative 17 over 2.
Pardon the interruption, quick announcement. We've added one more to our pie in the face. Don't forget to stop by the table. Officer Blue has been added. So we have Hopper,
Yeah, let's put
GL,
pie in the face of the guy
Emmons,
with the gun. That's it.
Officer Blue, Walls, Wilder, and Gray. Thank you. We will be doing this until tomorrow after lunch.
All right. So they asked us to find the length of the base. We found the height, so the length of the base would be 2 times 12 minus 7, which is 17 centimeters. This is our base. And that's what they're asking for. So the 12 centimeters is really not my answer. The 17 is. Yeah. I know. Actually, whatever is in there. Yeah, so. All right, let's go with, I could edit it, but I don't. Hypotenuse of a triangle is 1 foot more than twice the length of the shorter leg. So when it says the word hypotenuse, we know what kind of triangle do we have? A right triangle. It tells us that it's a right triangle. And it says the hypotenuse is 1 foot more than twice the length of the shorter leg. So you just got to, say, okay, this is the shorter leg. I'm going to call it X. And then the hypotenuse is 1 foot more than twice the length. So which one of those sides is the hypotenuse? The big slanted one that's across from the 90 degrees. So that one over here. So what would be the expression for it? 2x plus 1. And then the other leg is, longer leg is 7 feet longer than the shorter leg. So that would be x plus 7. All right. Yeah. Well, I mean, you could use whatever letter you want to use. If you want to use S for swinging, you can. Yeah. Okay. Says find the dimensions of the triangle. So we need to find all three sides. That's what we're looking for. Uh-oh. They didn't give me any other information. They didn't give me an area or anything to deal with. Not as answers. I don't have an area. I don't have an area number to get it equal to. So I don't have enough information to do that. Not a trick question. Think about what kind of triangle do we have here? So what do we know about right triangles? How do they equal the hypotenuse? There's a relationship there. You know, but you don't know the name of it? Okay, does anybody know the name of that? Yeah, Pythagorean Theorem, a squared plus b squared equals c squared. That exists. It works for right triangles. We have a right triangle that we can use here. So A and B are what parts of the triangle? The legs, right? And the C is the hypotenuse. Okay, always. So I'm going to set that up. I got x squared plus x plus 7 squared equals 2x plus 1 squared. We're using Pythagorean theorem here because we have a right triangle. Now, what do I do now? Multiply all that stuff out. Because it's a side length. So we got x squared plus 14x plus 49. And this will be 4x squared plus, because it's got addition in between it. The square root of x squared plus something else squared does not get rid of the squares. The whole side would have to be squared separately if that were the case. All right, now what? Like terms, that's a good idea. 2x squared, 14x plus 49. Now what? Subtract what? Okay, so I can move to either side, but I want to get it equal to what? 0. So it's about the same. It's the same number of steps no matter which direction it go. If I'm going to try to use factoring later on, what do I want the number in front of x squared to be? Yeah, it's a lot easier if it's positive. So I'm going to move the 2x squared and all its friends. And get 0 over there. So that's 2x squared minus 10x minus 48. What do we know about all of those numbers? They're all divisible by 2. So I'm going to divide everybody by 2. Just to make my numbers smaller, makes it an easier problem to do. And it also helps me if I'm going to do factoring because I get the shortcut now. Negative 24, add to be negative 5. Does that. All right, 3, negative 8. So my factors are x plus 3, x minus 8. So x plus 3 equals 0, x minus 8 equals 0. Negative 3 and 8. Which one of those do we throw away? Negative 3, because that x represents one of my dimensions. It's one of the shorter leg. So we're throwing that one out. So we have dimensions of 8. What are we dealing with? Feet, because it says foot, 1 foot more. And then that's the shorter leg. And then the longer leg would be 8 plus 7, which is 15 feet. And then the hypotenuse is 2 times 8 plus 1, which is 17 feet. Not just the dimensions. That's all I asked for. So these application problems are not quite, as daunting as you may have been thinking they would be. But they're still, nice. All right, number 6. The height of a rectangular prism is 3 feet. The length and width can be expressed as x minus 1 and x plus 4. If the volume of the prism is 198 cubic feet, find the value of x. Ooh. Ah, this is not that bad. What's a rectangular prism? What's another name for it? A box. Okay. A rectangular prism is just a box. All right, so we got a rectangular prism. They tell us that the height of that rectangular prism is 3 feet. So that's how tall it is. The width can be expressed, and the length and width can be expressed as x minus 1 and x plus 4. How do you find volume of a rectangular prism? What's the formula? Yeah. We have all of those things. We have the volume. We have the length, width, and height. So x minus 1, x plus 4, 3 was 198. What can I do with that 3? I can divide it because 198 is divisible by 3. And that'll help me a little bit. So x minus 1, x plus 4 equals 66. Is that right? Now what do I do? All right, I got to multiply that stuff out. So x squared plus 3x minus 4, 66. Take away 66. X squared plus 3x minus 70 equals 0. And that looks like it'll be an easy one to factor. What are our numbers? What does that? What? No. Say it again. 10 and negative 7. Yeah, the negative needs to be on the 7. Good job. So that we can take the shortcut. So x plus 10, x minus 7. So x equals negative 10, x equals positive 7. And we know it can't be negative 10 because that would end up with negative values when we plug that back in. Negative 10 minus 1 is negative 11. So that's out already. 7. And then what does it ask us for in the problem? What's the question? Oh, so we're done. We don't have to find the dimensions on this one. Be careful of that. What you answer the question that's asking the problem. Be careful of that. Because a lot of times you can stop too soon, or you can go further and cause yourself more work than you really have to. Okay. All right. Number 7. Yeah, because most vegetable gardens are rectangular in shape. So, rectangular shaped vegetable garden. We have a rectangle. It's a vegetable garden. It has dimensions that are 15 feet by 9 feet. Ken wants to increase the area of his vegetable garden by increasing the length and width by the same amount, x, so that the new garden has twice of the current area. Well, what's the current area? 15 times 9 is how much? 135 square feet. So we want a new garden that is longer and wider, but we want the area to be 270 square feet. How do I know that? Yeah, I want the area to be twice as much. So I doubled 135. But I'm doing what to the side lengths? Making them bigger by how much? Same amount. That amount is x. So I have 15 plus x up here and 9 plus x over here. They want to know how much to add to each side to the nearest tenth of a foot. Okay, so let's set up our equation. So I could write this x plus 15, right? And x plus 9 is the same thing. It looks better to me to do it that way. Okay. We're setting that equal to 270 because that's the new area of our expanded garden. Now what? Distribute, multiply that out. So x squared plus 24x plus 135 equals 270. And then subtract the 270. X squared plus 24x minus 135 now equal to 0. We've been using factoring all day, so let's try that again if it helps us here. I have a sneaking suspicion, since they said to the nearest tenth of a foot, it probably may not factor, or if it did, I've got fractions answers. But I know that I don't get fractions when there's nothing in front of x squared. But if I try to multiply to be negative 135 and add to be positive 24, it doesn't work. Okay, so what's my other option for solving? Quadratic formula. So I need to find the discriminant. So 24 squared minus 4 times a times c. That's going to help me do the quadratic formula. So 24 squared minus 4 times a times c, which was negative 135. 1,116. So when I do my quadratic formula, I got x equals negative b. Whoops. Negative b. square root of 1,116 over 2 times a. Does 1,116 have a good square root? It does. Okay, so we're going to need that number in a minute. Let's do the work here. So we have negative 24 plus square root of 1116. Both of those divided by 2. I'm going to reduce that to be negative 12 plus or minus, excuse me. So that'd be negative 12 plus or minus the square root of 1116 over 2. Those are my 2 answer possibilities. Which one of those will give me a positive answer? The negative 12 plus or the negative 12 minus? Yeah, because negative 12 minus something is going to give me more negative, right? So that'd be so I only need to do x equals negative 12 plus square root of 1116 over 2. So I'm just going to do that work. Negative 12 plus the square root 1116. Get out of that, divided by 2. Enter. 4 point, and it said round to the nearest tenth of a foot. So approximately 4.7 feet is how much we should add to both sides of that. That makes some sense. Now, somebody said first block, they said this. They said, well, why would you just kind of guess at it? You get close, right? What would be a reason that you would actually want to calculate a little bit closer than about 5 feet?
Human neighbors, they own some of the yard.
That's a very, nobody said that first block. That's good. Think about that. What if you owned a greenhouse?
You have so much space.
You only have so much space. You want to maximize what you're growing in a certain area because you know how many shrubs or mums you can grow in a certain area. So you're trying to maximize that area and you want to increase a certain part of the garden there. So think about when you're running a business, you've got certain things that you want to try to do. And, I don't know how many business people do this, but they probably hire somebody to do something like this. Civil engineer or something gets paid a lot more than I do to do the same stuff. Sad. All right, let's look at number 8. This is an ACT-ish type of question. I've seen problems like this on ACT. Several of the practice tests that I've looked at and the retired ACT test. So I've seen a lot of problems that look like this. So given the diagram below, the area of the shaded region is 59 inches squared. What are the dimensions of the outside rectangle? So the bigger rectangle is what we're trying to find the dimensions of. So how do we do that? Thanks, Wayne. She's not so confident about this. So go ahead.
X plus 4 times x minus 1 equals,
But okay, so he said x plus 6 times 2x minus 1. That'll get us the area of the big triangle or big rectangle, right? Is that the area of the shaded region? Not quite. Barrett, what do you got? Why do we need to say it again? Minus what?
Minus x plus 6 times.
Why x plus 6 times that?
Because that would be the area of the non-shaded region.
What's the length of the non-shaded region? It's a little harder to see on y'all's handout because it's a 3. So what Aiden is saying is take the area of the big rectangle, like Eli said, so 2x minus 1 times x plus 6, and then subtract away the area of the white rectangle, which would be x times x plus 3. And that would be just the shaded part, which we know is how much? 59. So we're taking the area of 2 different rectangles and subtracting them. And that's going to build us what we need. So this will be 2x squared plus 12x minus 1x would be plus 11x minus 6 minus x squared plus 3x. Notice that I put the minus and then parentheses there. Why did I do that? Did I like making it look complicated? Well, true. What are we really subtracting there? What's the part in the parentheses and the blue line? What is it representing? What does it represent? So it represents the area of this little box. So we're subtracting out the area of that whole little box. If we only subtracted x squared, it wouldn't get the whole box. It would, and we didn't put the minus sign on the 3x. So you've either got to have a minus sign on x squared and a minus sign on 3x, or that going on to do it right. Okay. So combining like terms gets us to x squared plus 8x minus 6 equals 59. And now what? Yeah, subtract 59, because we got to get it equal to 0, right? Well, if we want to use factoring or quadratic formula, we do. It'd be 65. And let's try factoring again. It may not work, but maybe it does. Negative 65 and add to be 8. It ends in a 5, so it's a 5 goes into it 13 times. Which one should be negative? The 5, because we want it to add to be a positive number, so the bigger number's got to be positive. Can I use my shortcut? Oh, yeah. X minus 5, x plus 13. So x equals 5 and x equals negative 13. We know that negative is out. Is that the answer they're looking for? No. What are they looking for? Not the area of the outside, but the dimensions. So the length and the length and the width of that. So 5 plus 6 would be 11 and inches. And 2x minus 1 would be 9 inches. Our dimensions. All right. Not bad. Easy thing. All right. The last two are maybe a little tougher. I don't know. Got to have an understanding of integers and how we get there. So number 9 says find 2 consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger integer is 24. What the what?
It says positive odd integers.
Yeah, because you could have negative odd integers, right? Like negative 3 is odd and negative, right? So it's saying they're telling us they're both positive. Now, could you find the answer to this without an equation? Oh, what the? Well, I think through maybe some guessing. But I mean, you got all the numbers in the world, and you're just guessing some odd ones. You might run into that, but it's probably not very likely that you get them. So let's set up an equation for this. So if we're dealing with 2 consecutive positive odd integers, the first one, let's call it x. So let's take, for example, if x were 7, what would be the next consecutive odd integer? 9. How do I get from 7 to 9? Add 2. So the next one, since we don't know what the first one would be, the next one would be x plus 2. If there were a third one, it'd be x plus 4. That sort of idea that we continue. If the setup works the same way, even if it's talking about even integers, it doesn't really matter. It's x and then x plus 2 for the next one. Okay. So it says that the square of the smaller integer, which one's smaller? X, so that's x squared, added to 3 times the larger one, so plus 3 times x plus 2 is 24. Okay, so we got a problem to solve. X squared plus 3x plus 6 equals 24. Subtract 24 minus 18. Multiply to be negative 18, add to be 3. Yeah, 6 and negative 3. Good job. So x plus 6, x minus 3. And they told us that the integers were what kind? Positive and odd, right? So the 3 is the 6 is neither positive nor odd, so it's out. So this is or negative 6, and this will be x equals 3. This one's out. So 3 is the first one, and 5 is the second one. Let's look at a harder one. Number 2. 3 consecutive positive integers, just positive integers, such that the product of the median integer and the largest integer is 72. Ooh. Okay, so we don't know what these integers are, so let's just call the first one x. What would the next one be? X plus how much? It doesn't say odd or even, right? It just says positive integers. So if the first one was 2, the next one would be 3. So you'd add 1 to get there. And the next one would be 4. To get from 2 to 4, you add 2. So here's the first, second, third. If there were a fourth consecutive integer, the x plus 3. All right, it says all right, so now we got to set up a problem. It says the product of the median integer and the largest integer is 72. Which one is the median? Middle. Remember, median means middle. So the middle one would be x plus 1. And that's multiplied times. How did I know to multiply those two together? Says the word product says multiply. Okay, and it's equal to 72. Splash that out there. X squared plus 3x plus 2 equals 72. Subtract. And this looks like one we've done before today. Negative 70 had to be 3. 10 and negative 7. So x plus 10, x minus 7. So x equals negative 10, x equals positive 7. And it asks us find all 3 integers. So what are the integers? And 9. That's about as tough as the consecutive integer things get, really. Just read the problem, set them up the way they give you the information out of that. Okay. All right. We will do projectile motion and the regression stuff tomorrow. I'll go ahead and give you the homework or the practice for this, so you get a little time to work on it, and then tomorrow we'll do the other parts.